Hi, my name is Dinesh Garg. I'm a student at E63 Big Data Analytics 2015 class. And today I'm going to present to you my final project, which is live Twitter emotion trends using Apache Storm. So this is what's going to be the agenda of my presentation. I'm going to talk to you about what is Apache Storm, how it works. Then I'm going to walk you guys through my project. And then we'll talk about a little bit of benefits and challenges, and we'll look at the resources that I've used. So what is Storm? Storm is a free and open source distributed real-time fault-tolerant computation system. Think of Storm as something for um, real-time processing of unbounded stream of data. So it's pretty much what Hadoop does for batch processing. Storm does it for the real-time unbounded stream of data. The way Storm works is it works as a topology where a stream of tuples starts from spouts and they go through multiple bolts for real-time computation. And the bolt can be doing anything. It can do some kind of computation, some filtration, and even finally saving some stuff to the database or some other location from where you can further use that data to do some sort of visualization. So the high level Storm abstractions are there's something called topology. The logic for a real-time application is actually packaged into the Storm topology. And topology is nothing but a network of spouts and bolts that I just talked about. Um, excuse me. So think of Storm topology as analogous to map reduce jobs. The key difference is that map reduce jobs eventually finish and they do some sort of batch processing on an existing data, whereas the topology just keeps on running forever and it keeps on working on the unbounded stream of data. So the tuple is the main data structure in Storm. It's the basic data structure. It's basically a name of it's basically a list of values where each value may be of any type. What is stream? A stream is a core abstraction again in Storm, and it's nothing but unbounded sequence of tuples that is processed and created in parallel in a distributed fashion across the bolts and the spouts. We already talked about spout and bolt. Spout is the source of streams, the initial source of streams in a topology. It can basically read from any kind of queuing broker, maybe Kestrel, RabbitMQ, Kafka, or any other source. What are bolts? This is where you actually do all your processing of the topologies. It processes any number of input streams and produces any number of new output streams. And as I just explained, it can do any kind of things. It can be some functions, it can apply some filters, it can do some sort of joins, aggregations, or it can talk to databases and so on. Now, whenever we are passing data from one component to another, there are different kind of groupings that we can apply. I'm gonna talk about a couple of different groupings which are significantly used. There's something called shuffle grouping, and shuffle grouping is something where tuples are randomly distributed across the bold's tasks in a way such that each bolt is guaranteed to get an equal number of tuples. So in this particular grouping, it doesn't really matter that tuples coming from one source go to which particular bolt task. Wherever we don't care about that, we just want to make sure that tuples are equally divided among different tasks. There is another kind of grouping which is very interesting, which is fields grouping. Um, in this case, the stream is partitioned by the fields specified in the grouping. For example, if the stream is grouped by user ID field, tuples with the same user ID will always go to the same task. And this is something you want to do, and actually I have used this in my project also. You want to do it, for example, when you're doing counting of words. So you want to make sure that a particular kind of word always group to the same task, which same bold task, which is actually calculating the count of those words, so that the same word doesn't go to two different tasks and get to count it twice. So these are two main kind of groupings, but there are, I think, in total there are 7 groupings, and these are just the two main I wanted to explain here. Okay, so these are the storm execution concepts. I'm sorry, yeah. So continuing on the storm execution concepts, the other concepts are reliability, um, you know, Storm guarantees that every spout tuple will be fully processed by the topology. It does this by tracking the tree of tuples triggered by every spout tuple and determining when that tree of tuple has been successfully completed. Each spout or bolt executes as many tasks across the cluster. Um, each task corresponds to one thread of execution. So basically, each of these can provide parallelism by um, running multiple tasks. There's something called workers. Topologies executes across one or more worker processes. Each worker processes a physical JVM and executes a subset of all the tasks for the topology. There are 3 different kind of nodes that are used in a distributed storm setup. There is a master node, which they call it as Nimbus node also, and this is the node which basically uploads the computations for execution and distribute code across the cluster that's being set up. The other node, which is usually familiar with everyone who knows a little bit about distributed computing, is the zookeeper, which is pretty much used to coordinate the storm cluster. And the other nodes are the supervisors, um, and these are the nodes which communicates with the Nimbus, which is the master node, through the zookeeper, and basically it starts and stops workers according to the signals from Nimbus node. So think of supervisors really as a slave nodes, which work based on what Nimbus node defines. There are 2 different modes in which you can run Storm. There's a local mode and a distributed mode. In local mode, Storm executes completely in process by simulating worker nodes with threads. Local mode is usually used in testing and development of topologies. It's not really used in the production. It's the distributed mode that you would usually use in the production environment, where the Storm operates as a cluster of machines. Okay, so how do you set up Storm? So you can basically go to this website, just download the Storm tarball. If you unzip it, as you can see in the figure, um, uh, this is the directory structure that comes up. There's a bin folder, you should be adding that to the path, and there's a lib folder which contains all the jar files that you may need to do the development. There is an external folder which I haven't used, but basically you can use it to connect to HBase, HDFS, Kafka. So it has libraries to connect to these things. And then there is a conf folder which may be used to set the configuration of Storm execution environment. If you're new to Storm and you're starting on self-development, I would highly recommend to going through the Storm Starter. This is a project on GitHub. It's really helpful. It has really some great examples, and I've actually used this to learn about Storm and get kick-started on my project. So talking about my project, this is how my project structure looks like. As you can see in the diagram, I have kept different packages for boards, spouts, and the topology. And as you can see, I have referenced the libraries from the Apache Storm that I downloaded. I'm also using the Twitter4j library because I'm trying to get the sample Twitter stream um, uh, from the actual Twitter account. So let me talk about what my project is all about. In this project, I've used a sample Twitter stream to generate a stream of English tweets from a spout. This input stream goes through a topology containing multiple computation pools, which reads the tweets and finally spits the count of some emotions related to words, which gives an idea of how emotions are trending on Twitter. So I'm really trying to show you that, um, it, you know, as the time passes, as you keep getting more and more tweets, how the emotion trend goes, um, in those tweets. So the output that will be observing on the console, which is updated every time count of any of the emotion words updates. And as I mentioned, for reading the sample of tweets, I've used Twitter for J open force library. So this is how my topology looks like. There is a spout that reads from the sample Twitter stream, and then which goes to a board which splits each tweet into words, and then basically there is another board which is filtering out the emotion specific words, and then the final board actually keeps the count of the words, and then prints that count on the console. So to be able to read the Twitter stream, what you need to really do is you need to go to apps.twitter.com and you need to create an app there. And once you create the app, you need to go to the keys and access tokens, as you can see in this diagram, and you need to generate those keys and tokens, which we'll be using later on in our code. This is how my topology looks like. I executed the live Twitter emotion trends in local mode in my Eclipse, and I can actually take you guys to my actual project now. So this is how my Eclipse setup looks like. This is how my topology is, in which I'm creating a spout, I'm creating the different bolts, um, and then I'm calling all these um, to define my topology. And since I'm running in a local mode, I'm just sleeping it for 5 minutes, and then eventually doing a shutdown on the cluster. Um, but of course, we can very easily and quickly put it on a distributed mode as well. So let's go ahead and run this topology and see what happens. Give it a few seconds to get started. So as you can see, it has started now, and initially it's just doing some initial setup for the local cluster that it's gonna create for the local mode. But very soon you will start seeing that it will start spitting some words with their counts, as you can see on the console, and it's telling us that, for example, the count of love at this point is 7, the count of happy is at this point is 2, and the count of hate at this point is 1. So as you can see very easily, the kind of emotions that are flowing on Twitter is that more and more people are talking about love and happy, and very few people are also talking about hate. So that kind of gives you an idea that most of the people um, kind of are using some positive emotions or are going through some positive emotions. So, and this is regularly updating itself based on what new Twitter stream is coming into it. So that's the pretty much gist of the project that I have done. Now again, this is just a screenshot of what the live demo that I've just shown you. That's about it. So let's talk a little bit about the benefits of Storm. Um, there are extremely broad set of test cases that exist, where Storm can be used. Um, it's highly scalable. It guarantees no data loss, so that's a great thing. And then it's fault tolerant. So if one machine goes down, it automatically takes care of those scenarios. And it's programming language agnostic. So basically, any of those bolts you can pretty much write in any popular languages which are used in the distributed systems, which is really a great thing. So you don't have to really run a particular language to be able to use Storm. These are some of the challenges based on the work that I have done and the knowledge I gained about Storm, one challenge that at least I faced is that Storm Javadoc API documentation of classes is not complete, which makes it a little difficult to understand how exactly we may use those APIs. So I think initially there's a learning curve, but after that it's really fun. The other challenge that I face is it's hard to provide an intermix of high throughput stream processing, manipulation, and low latency querying. So it's hard to combine these three things. Um, Although there is a library, a framework named Trident that exists, which is pretty much a wrapper over Storm, which processes the real-time data in mini batches, and which really strikes a balance between these three things. So if you want to do that, then that's the way to go. But yeah, initially, if you're just using Storm, but you're gonna face this challenge that how to balance these three things. So that's pretty much all I have from my uh, you know description of Storm, then my project, and how to do the setup and stuff. So I think once you go through this video, I hope now you'll be able to very easily get kick started on how to use Storm. These are the YouTube video demos. There's a short video also that I prepared. If you want to go take a look there. And these are some of the resources that I used to be able to come up with all these presentations and to be able to do my project and learn Storm really how it works. Well, that's all I have. Thanks a lot for listening in. Have a good day. Thank you, guys.